Hello all. After knowing about full adder and full subtractor, now we'll be dealing with parallel adder and parallel subtractor. So, as we have seen before that half adder deals with two 1-bit input. Similarly, full adder deals with three 1-bit input. What if the input is more than 3? So in that concept, we'll be using or dealing with parallel adder. For example, I have a decimal number say 10 and another decimal number say 5. So what is 10? 10 is 1010, that is 4-bit number, and 5 is 101, that is 3-bit number. So in this, if I compare, here A is a 4-bit number and B is 5 is of 3-bit number. So what I will do is, first I will need to make 5 as a 4-bit number. So how will I make it as 5 as 4-bit number? By simply adding 0. Just as the MSB, I will be writing as 0 but on the left hand side. So after I get both the inputs to be 4 and concept of parallel adder is based on full adder. Like how many maximum bits are there, that much of full adder you need to use. As full adder, like the total number of inputs are 4, so that means for full adder there will be 3 inputs and 2 outputs. So let me draw 3 inputs. As you can see here, I have connected this full adder. So this is FA0, this is FA1, this is FA2 and this is FA3. So as you can see, full adder 1, the output is connected to the input as the full adder 1. That is, for full adder FA0, let the inputs be A0, B0 and let the carry in, that is the third input of the full adder, be 0. That I am providing the input as 0. So it will be having two outputs. Say this is S0 and this is C0. So C0 will be acting as the third input for the full adder 1. The other two inputs will be A1 B1, similarly A2 B2 and A3 B3. Now the output of, that is carry of FA1, will be acting as the third input for FA2. That means the output of carry will be acting as the input for the corresponding full adder. So here will be S2, this will be S1, this is S2, this will be C2, this will be S3 and this will be C3. Let this 10, that is, let the values be something A3, A2, A1, A0. Let 10 be A. The corresponding bits are 1, 0, 1, 0. Let the value of 5 be B. And the value is 0, 1, 0, 1. Let this be B3, B2, B1 and B0. So if I simply add, first let me perform the normal addition. It will be 0 plus 1, 1. 1 plus 0 is 1. 1 and 1. Let me provide the input corresponding in this full adder and see the output, what will be happening. So 1 0 1 0 and this is 0 1 0 and 1. So if I see the output, 0 plus 1 plus 0, my sum will be 1, the carry will be 0. Similarly 1 plus 0 plus 0, sum would be 1, carry would be 0. 0 plus 1 plus 0, sum would be 1, carry would be 0, and 1 plus 0 plus 0, sum would be 1 and the carry would be 0. As you can see the outputs 1 1 1 1 1 1 1 1. Answer is same. So this is the way how we performed multiple bit given inputs addition using parallel adder by the concept of full adder. Note, you need to keep in mind, like maximum number of bit, that much amount of full adder you need to use. Suppose if it would be a 5-bit input, then you need to use 5 full adder. If it would be 6, corresponding 6 full adder. Hope this video is clear to you all. Thank you.